Hello, welcome to our lesson today dealing with multiplying integers. This is in section 1.4 in your textbook. We're going to spend a few days looking at multiplying integers. I just want to make sure this first day we've got all the right ideas, and then the second day we'll kind of extend a few topics about integers and multiplication. If you think way back to elementary school, back when you first learned multiplication, which for a lot of us is kind of hard to remember because multiplication becomes so natural to us. When you first learn to deal with multiplication, typically what happens is we learn how to deal with repeated addition. So for example here, 6 plus 6 plus 6 plus 6 is 24. And we typically would write that 6 times 4 groups of it. The same is true with negatives. So for example, this one here, this is actually negative 7 times 2, or 2 groups of negative 7. And it's just repeated addition of the same numbers. So all 6 of these showcase that idea. And really that's how multiplication works for integers, the same way it does for whole numbers. So let's look at this idea. If you have 3 times 2, that's 3 groups of 2, which is 3, 2 positives, 2 positives, 2 positives, and add together that equals 6. 3 times negative 2 is easy to explain to someone for a similar reason. It's 3 groups of negative 2, so negative 2, negative 2, negative 2, and that becomes negative 6. The one that's odd is what is negative 3 times negative 2? And the best way to describe this is a negative sign should always do its opposite. So if you look here, 2 becomes a negative, and notice it flips to a negative. But then the 3 also becomes negative, and it has to do the opposite. And so the idea is every time you multiply by a negative, it kind of flips things around. Think about a number line. So the answer should be 6, but then you multiply by negative and it makes it negative 6. And then you multiply by negative and it makes it a positive 6. Because there's only one way to go, or two ways to go, either to the positives or to the negatives or vice versa. Okay, and it has to go that way. So when you're dealing with multiplication, the idea is that a positive times a positive, that one's easy, should be a positive. A negative times a negative, that's the weird one, and that ends up being a positive, which is where some of you may have heard, oh, 2 negatives make a positive. Well, that's for multiplication. The way that I love to explain this is if you've ever been to a reunion or a family gathering, and you have what I like to call, or other people call, a negative Nancy. Have you ever heard of a negative Nancy? That's someone that's always negative. Now, if you're like me when you get to these functions, as soon as I figure out a negative Nancy is there, I try to avoid that person at all costs because I don't want to be talking about how horrible everything is going for them constantly. They could have won the lottery and they'd find a way to complain about it. Okay, so that situation is like this. Okay, if there's one positive person and one negative person, I'm still in a negative situation because they're still talking to me about negatives. Or vice versa. Commutative property says you can switch the order, it's the same answer. However, the negative Nancy idea has a great effect on if there is only one and I have a negative outcome. What happens with negative Nancy's, though, is if you've ever been in this situation, it makes perfect sense to you. If there comes through the door a second negative Nancy, all of a sudden the two negative people talk to each other. And the negative people will talk amongst themselves. And so if they're paired up, those two negatives will actually make the rest of us happy. Because they can be negative by themselves, essentially, and the two negatives will counteract and make the rest positive. Now notice, it's only two. Okay, there may be an issue if a third one comes into play, for example, but in general, okay, let's start with 2. You also might notice that 0 times any number should be 0. That should be the easiest group. Okay, 0 times any number should be 0. Okay, so really all I'm going through is a bunch of questions. What you want to look at is really you just ignore the negative signs, multiply as if they're whole numbers or positive integers, or 0, and then slap on a negative sign if it needs it. Okay, so for example, 7 times 5, easy, 35. Negative 4 times negative 6, you just multiply those things together, you get 24. It's positive because two negatives, negative times negative is positive. The last one here, I circled it because it seems to show up a lot with the common denominators and whatnot. So don't forget that 13 times 7 is 91. 91 is not a prime number. The other one that's not prime is 51. That's 17 times 3. And when you're taking 17 times that 3-digit, it ends up being 51. Don't forget about your rules with 3. So if a number is divisible by 3, if you add up all the digits, it's also divisible by 3. So that's a negative because there's only one negative number, and that makes the entire number negative for an answer. Next, 4 times negative 8, so negative times a positive should be a negative answer. This one here, I would challenge you to make sure that you find the answer of 943. Multiply those two-digit numbers. Notice you don't need to care about the negative until the last moment. And then negative 8 times negative 3 is 24. What you will notice on most of my questions is I don't put the first number in parentheses. It's not wrong if you do, but you typically won't see it as often. The reason the other numbers have to be in parentheses like this is because you have to show multiplication somehow. And when negative numbers get involved, we don't want to guess if you meant subtraction or how you meant to write it. So I tend to use parentheses to do that, and I encourage you to do the same. What you probably want to start to avoid doing is using the x for multiply, though, because that's going to be a variable soon. Okay, the next questions just have more than two numbers. Here's my suggestion. You can multiply in whatever order you want. The associative property says that. So in this question, I'm going to multiply the 5 and 3 together because that will get rid of two negatives and make it positive. And then 8 times the 15 will be 120. Obviously, you could go left to right and find that answer as well. And if you struggle with order of operations, I would recommend going left to right. The second one, I'm going to multiply 8 times 7 first just because I noticed it. 8 times 7, for whatever reason, is one of the hardest one-digit multiplication questions. Remember, 7 times 8 or 8 times 7 is 56. Times a negative, that'll make this a negative. 112. The important thing about this scenario is making sure you have to know that answer is negative. Is it obvious to you that the answer should be negative? And the answer should be yes, because there's one negative person. The last one, I just went kind of left to right. I multiplied some things together first, so I multiplied these two. 10 and negative 2 become, or I'm sorry, 5 and negative 2 become 10. You'll notice the next step I kind of switched, and I did negative 4 times negative 12. The associative and computer properties, I can switch things around as long as it's only multiplication. I chose to do those ones first, though, because that gets rid of all the negatives. Notice in this question there's 4 negatives. 2 of them pair up, become positive. The other 2 pair up and become positive. So if there's 4 negative Nancys at the party, we're good. It's if there's an odd amount that we have a problem. Okay, so as long as there's an even amount of negative, it's going to become positive. And then your answer should be 2,880. The other thing to make note of is look at all the work I've shown here. I know this drives some of you crazy about showing work, but you're going to have a lot more success about your organization if you figure out ways to show your work and you can systematically do it like this one. If you have an open-ended question like on a test, okay, you can also do that and show your work in a similar fashion, and I'll know exactly what you're looking at. So make sure you work on showing your original problem and your work as you look at these questions. Okay, so your homework today, section 1.4, notice it's 8 through 23, that's all. As long as there's no odd here, it means all of them. Obviously, you can't check all the evens, but if the odd ones are looking good, make sure you do the evens for practice. And then there's 4 questions at the end that deal with review. Make sure you work on those pieces. Don't forget to write the original problem. That's the assumption that you're going to always do. The numbers here are pretty easy, but make sure you try your questions without a calculator first, okay, before you start checking things with a calculator. Have a good day, everybody.